Hey there, Algebra 1. Today, you guys, we are going to be working on our 1.5 notes. So please make sure you have those in front of you before you start watching this video. Okay? All right. So we have been working really hard on solving lots of different types of equations. And we are going to keep using those same properties, but today we're going to start solving inequalities. Okay, so we'll kind of ease into it by using an equation to move into our inequality today. So let's look at our situation here. So Skylar here is a high jumper. And it says that Skylar competes in the high jump event at her school. She hopes to tie or break some records at the next meet that she's at. So they have her information here, her information is the bottom one, and the other records are the top one. So her personal best is 1.48 meters, and she's not too far from the district record. She's got a little ways to go to meet that state record. Okay. So part A says to write and solve an equation to find X, the number of meters Skylar must add to her personal best to tie the district record. Okay. So right now, her personal best is that 1.48 meters, and the district record is the 1.57 meters. Okay. So we're trying to figure out how much higher does she have to jump. So she can currently jump 1.48 meters. She needs to add a certain amount of height to equal or tie that district record of 1.57. Okay, I'm going to switch to red for solving. Remember, it's always a good idea to draw your line. And to get x by itself, I have to get rid of this 1.48, which is positive right now. So I'm going to subtract it. And if I punch this in my calculator, I'm going to get that she needs to add, ooh, that's a horrible decimal point, 0.17, let's be specific, meters. Okay, which, by the way, is about like 6 or 7 inches, somewhere in between there. Okay, so it's 6 or 7 inches is kind of significant in high jump. Okay. So let's look at part B. So now it says to rewrite your equation as an inequality to represent the situation where Skylar breaks the district record. How is the value of x in the inequality related to the value of x in the equation? Okay, we'll come back to that second question here. But it wants us to rewrite our equation with an inequality. Okay, so if you remember, we have inequalities like this. This first one I listed is greater than, and the second one is less. Nope, I have those backwards. My bad. Greater than looks like this, and less than looks like this. We also have ones that are like greater than or equal to, where it has that line underneath. Okay. All right, so it says to write it as an inequality to represent a situation where she breaks the district record. So I'm going to I'm going to go back to black. I'm going to rewrite my equation. Okay. But instead of an equal sign, I want to show where Skylar, her and her jump is greater than or bigger than this district record. So we're going to have to replace that equal sign with a greater than symbol because we want Skylar's height to be bigger than the district record. That's the only way she's going to break the record. Okay. Now, believe it or not, we can actually solve this just like we solved the equation. We're going to subtract 1.48. But now the difference is that my answer is that x is greater than 0.17 meters. That means that she has to jump higher than that. Okay, so she must jump higher than that. Otherwise, like, tying is not the same thing as breaking the record. So she has to jump quite significantly higher. Now that I'm looking at it, the 0.17 doesn't look right. Oh, you know what, guys? I'm sorry. My calculating is off. To reach that, she needs 0.09 meters. Sorry, this is why you guys should always check it yourself, okay? 0.09 meters. I don't feel like that's very high. Okay, that's about 3.5 inches. That's still quite a bit when you're high jumping, but anyway. Okay, so how many meters does Skylar need to add to her personal best to break the state record? Ooh, the state record. Okay. So to break the state record, that means she has to jump higher than the state record. We're going to say our inequality is going to be her current personal best plus X. We don't know how high she needs to jump yet. Needs to be greater than or higher than the state record, which was 1.75 meters. So we're going to subtract 1.48 and get that she must jump 0.27 meters at least. So actually she needs to jump over that. So she needs over 0.27 meters. We're going to practice some more with solving these inequalities because there are some things about them that are slightly different than solving equations. And most of it has to do with how we write our answer. Okay, so let's flip over to the back of that first page. We are going to solve both of these inequalities. And I'm going to draw a line in between them so I don't get them mixed up. And I'm going to write some stuff off to the side. Okay? So make sure you leave some room over there on the left because we're going to have to write some notes in there. Okay. But I'm going to start with that first one, letter A, and we're really going to start it just as normal. Some of you might start with dividing. I think I'll start with distributing. And if you want, you can still draw that line through that inequality sign. Just don't forget to keep writing the sign. Don't switch it to an equal sign. Those are some common mistakes I see. So if I distribute, I'm going to get negative 6x minus 6 is less than 10. I'm trying to get x by itself, so then I'm going to add 6. And I have negative 6x is less than 16. And I'm going to divide by negative 6. Okay, now here's where we have our first difference. So, well, first off, let's do 16 divided by negative 6 is negative 2.6 repeating, which is negative 2 and 2/3. 0.6 repeating is 2/3. But the first thing that happens is different. When I multiply or divide by a negative number, I have to switch the sign or flip the inequality sign. Okay, so this sign is going to now face the other way and look like this. Okay. And here's the reason why. Let's say I had, I'll just give you a short, quick example. Let's say I had that 1 is greater than negative 5. Okay, we know that a positive number is bigger than a negative number. Okay. Well, they're like, okay, well, what happens if I want the 5 to be positive? So I'm going to divide by negative 1. And 1 divided by negative 1 makes negative 1. And now my 5 is positive. Well, now shoot, now I'm saying that a negative is bigger than a positive, and that's just simply not true, okay? So I have to switch that inequality symbol around in order for the statement to remain true. Okay. The other thing that is different about how we write our answers here is we're not just writing that x is greater than -2 2/3. We also have to graph our answer on a number line. Okay, so let me show you how I'm going to do that. So it involves two things. It involves a circle and an arrow. Okay. The circle, there's two types. If we use these two symbols, we're going to have an open circle. If we use these two symbols with the equal to's underneath, we're going to have a filled in circle. Okay. My symbol doesn't have an equal to sign, so I'm going to have an open circle. I'm going to put my solution, my answer, that -2.6 repeating right here. And usually it's good to have a couple other numbers. I would say maybe just figure out where 0 is. Where would 0 be on your number line? So since this is a negative number, 0 would be over here somewhere to the right. If it was a positive number, 0 would be on the left. I have a greater than symbol with no line underneath, so I'm going to have an open circle right here. That's part of my answer. Because what this is saying that as long as x is bigger than -2 2/3, that answer will work in this inequality. So I'm going to point my arrow in the direction where all the numbers are bigger than -2 2/3, which happens to be this way, okay, because those numbers are bigger. If you're a little confused by the graphing, that's okay. We're going to try another one. I'm going to try this second problem. I'm going to distribute. I can draw my line through. Right now I have a greater than sign. 2 times 4 is 8. Minus 4x is greater than 1. I'm going to minus 8. -4x is greater than -7. And again, I'm dividing by a negative number now. So I'm going to have to flip this inequality symbol. So I'm going to have x is less than -7 divided by -4 is 1.75. Okay. I'm going to go ahead and graph my solution. I'm going to put a line there for the 1.75. I like putting that right in the middle so it's very clear that that's my answer. I'm going to put a line for 0. 0 is like over here somewhere. My symbol does not have an equal to underneath of it, so I'm going to make it an open circle. And this is saying that x is smaller or less than 1.75. So I'm going to point this way because that's where numbers smaller than 1.75 are. Okay. Let's try our next example. We're going to solve an inequality that has variables on both sides. And one thing I actually am going to do, we're going to change our inequality symbol just a little bit. We're going to put an equal to underneath, just so we get the practice. Okay. I'm going to draw my line. Now remember, with the variables on both sides, we want to get all of our variables together. I would think it'd be easier to subtract 2x. -5 is less than or equal to 3x minus 22. Now I'm going to add 22 to the other side. Let's see, -5 plus 22 is 17. Man, none of these want to come out to be pretty answers, do they? To get x by itself, remember that means 3 times x. I'm going to divide by 3 on both sides. It's not going to be very pretty. It's going to be 5 2/3 or 5.6 repeating. It's less than or equal to x. All right, now let's start with the graphing, then I'll talk to you about our answer and how it's a little bit different. So I'm going to start by putting a line for 5 2/3 and a line for 0, just so I have a reference point. I have an equal to symbol underneath, so this time I need to use a solid circle or filled in circle. Now, it really bothers some people to have the x be on that side of your equal sign or your inequality. If you want it the other way around, which also might be easier for graphing, you are going to have to remember that if you flip this around, you need to flip the inequality so it's still facing the same way. I can't have it saying that I can't just switch x and 5 2/3 without also switching their inequality. That makes it a different answer. So now this, either way you look at it, it's saying that x is the bigger of the two things. So I'm going to point in the direction of numbers that are bigger than 5 2/3. All right, you guys are doing really good. We got one more thing to talk about, but two answers sort of, okay? We also have to talk about what happens if we get a no solution or an infinite solution and what they look like, okay? You guys are accustomed to, in your equations, that if you get the same thing on both sides of the equal sign, it's infinite solutions. That may not necessarily be true, okay? What you're going to have to pay attention to for this is with the inequality symbol, is the statement true or is it false? If it's true and always true, that's going to be infinite solutions. If it's false, that's going to be no solution. So let's take letter A here. If I distribute, I'm going to write them under so I don't run out of space. I'm going to have negative 8x plus 4 is less than negative 8x plus 4. Okay, so look at this. We got the exact same thing on both sides of the equal sign. Or, I'm sorry, of the less than sign. Now, here's the thing. Now, we know our x's will cancel out, and honestly, our 4's will cancel out. We will eventually end up with 0 is less than 0. But 0 is not less than 0. 0 is the same thing as 0. But they did not give me an option of equal to on here. So because it's strictly saying, yes, 0 is less than 0, this is actually not true. You can't be less than or greater than something that you are equal to. So this is not true, making it a no solution. But on letter B here, if I distribute, I'm going to get negative 6x minus 5 is less than negative 6x minus 3. My 6x's cancel out with each other, and I have negative 5 is less than negative 3. Or if you finished it all the way, you'd have like negative 2 is less than 0. That is true. Negative 5 is smaller than negative 3. It's always smaller than negative 3. So this is actually going to be an infinite solution because it is true. Ooh, sorry, I cannot write today. So even though on the no solution we had the same thing on both sides, and on the infinite solution we had different things, you're going to have to pay attention to whether or not it creates a true statement. Now, if you guys have questions on your homework, please make sure you email me, and good luck.